work on today is the oscilloscope. I think there's 3 papers I sent, plus a formula sheet. All right, so this is what we're going to work on. Let's look at this number 1, the one you see on the board right now. Remember, this is alternating current. This is our sine waves. So just as kind of a quick little refresher, remember it's alternating current flowing one direction and then the opposite direction. All right. Remember we talked about having cycles per second, which is hertz, which is frequency. And then of course you have your amplitude. Okay, your amplitude, which is typically, we're talking voltage with this worksheet, because we're looking at a screen of an oscilloscope. Okay, so looking at this first one, just as a reminder, when you're doing this one, and it says calculate the frequency, okay, well, we need to know how many squares we have widthwise and what each square is worth. Of course, that's in centimeters. So right now we're looking at this and we say, all right, we have how many squares for this sine wave? All right, so if we start here, we end here, that's 1, 2, 3, 4 squares. So our sine wave is 4 centimeters wide on our oscilloscope screen. If you look over here, it says each square is worth 2 milliseconds. So how many milliseconds is that total? All right, take your 4 squares, multiply it by your 2 milliseconds. That's going to give you 8 milliseconds. So every 8 milliseconds, we have a sine wave coming out of our function generator. So what is the frequency for that? Now, I did send you guys, and you probably have it memorized. Again, this is all review. A sheet that looks like this. It was at the end. Those are the formulas you need. Okay? So you may want to be looking at that at the same time. So if we go back to this, what we now have to do is we say, okay, the period of our sine wave is 8 milliseconds long. Remember, you have to do the reciprocal of that. That's that button again on your calculator that you either downloaded or you have, the reciprocal button. All right, so put in your calculator 8 exponent negative 3. I'll do it myself. 8 exponent negative 3. Should look like that. All right. Then you're going to hit that reciprocal button. Okay. It equals, what is our frequency? I'm reading this backwards. I think that says 125 hertz. So that's what you're going to write here. So you have 125 hertz, which means 125 cycles per second, or 125 sine waves per second. Okay? So that's how you calculate your frequency. You take how many squares your width is for one complete cycle, one complete sine wave, one positive, one negative alternation, multiply it by your time per centimeter per division. You get 8 milliseconds, you do the reciprocal of that, 1 divided by 8 exponent negative 3, and it gives you 125 hertz, or cycles per second. Okay, now, that's time. Now we got to talk voltage. So, it says that each square vertically is half a volt per centimeter. All right, so let's change colors here. Now remember, this is 0 volts across here. So there's 0 volts. So when we are trying to figure this out, it wants to know peak. So all I care about is peak. So if right here is 0, and this point up here, right there is my peak, how many squares up did I go? Well, that's 2 squares, right? We went up 2 squares. You could use the negative peak as well, but it's still 2 squares. All right, so you're going to put 2 times 0.5, and that's going to give you, obviously, 1 volt. The reason I write it like that, remember, all of our oscilloscopes have probes that have, it says right on the probe, and I don't have one in front of me, I should have, it says times 1 or times 10. If you were going to measure higher voltages with a scope, you have to set it for the times 10, but then when you do the math, you have to remember that you just change your scope probe. And really what it does is it adds a precision resistor in there that cuts the voltage down so that the scope can handle the higher voltages. So right now it says our probe is set for times 1. So that makes it easy. So we have 1 volt peak. All right, let's do another one. Let's find another one here. That one's an easier one. That one's not too bad. Let's look at the last page. Actually, let's do that one. That'll work. That'll work. Okay, we have an issue here. Again, it wants to know our frequency. But if you're looking at that picture, you can see, we can only see half of our sine wave. If we start here and we end here, it goes off the screen. Okay, we can't see the other half. So what we have to do is figure it out. So how many squares do we have from here to here? Well, 1, 2, 3, 4, 5, 6, 7. It's 7 squares wide for the positive peak. So the negative peak must also be 7. Now, truthfully, what you should do is change the settings on your scope so you can fit it on the screen. But that's not part of the worksheet. Okay, so what do we say? 1, 2, 3, 4, 5, 6, 7 wide for half of it, which means the whole thing is 14 squares wide. Okay? So this says microsecond. Remember, micro is exponent -6. So with your calculator, we're going to put in, and I got to keep it in the light too because it's kind of dark the way I got to film this. 14 times 20 exponent -6 equals, worked out perfectly the way I wanted it to. What's that say? 2.8 with an exponent of -4. We don't use 4s. So what button you got to hit? Wherever it is. There it is, the ENG button. All right, so hit the ENG button, and that gives us 280 microseconds. Okay, so you're going to write that right here. So one sine wave is 280 microseconds wide. So then again, we got to use that reciprocal button, so we can do 1 divided by our 280 microseconds. So if you still have that in your calculator, just hit your reciprocal button. Does something like that. It equals, and there's your answer. What's it say? 3,571, if I can read it backwards correctly. So 3,571.4 hertz. 3,004 hertz, or cycles per second. So obviously it's a faster frequency. Uh-oh, look at this one. It wants RMS. Remember, we've gone over this. Scopes, oscilloscopes, read peak and peak to peak. But our multimeters, they measure usable power, as I like to call it, which is root mean square, the RMS value. So what we're doing is we need to take our scope voltage and convert it to RMS, which is the equivalent of what our digital multimeter would read. So remember the formula to convert that. You need to take your peak, whatever your peak value is, times 0.707 to get the RMS value. Okay, so we got to measure peak in order to figure out this RMS. So again, here's our 0 volt line. We went up 2 squares, right? We're going to do 2 times 5. That's going to give us 10 volts peak. Now again, remember, our probe is set for times 1, because some of them on the worksheet are times 10, right? So then you're going to take that 10 volts peak, and you have to multiply it by 0.707 in order to get the RMS value. Okay, so if you do 10 times 0.707, you're going to get 7.07 volts RMS. Root mean square. Let me see what else we got on this one. I don't want to solve this one. I'll let you, because there isn't that many to do on this worksheet. But if you kind of look at this, of course, this almost looks like it's half a square. So this one for peak shouldn't be too bad. But remember, when you were looking at these increments, that's 1 square, right? So you're talking 0.2, 0.4, 0.6, 0.81, 1.2, 1.4, 1.6, 1.82. All right, don't get hung up on those. So that's pretty much a quick run through of how to solve the AC oscilloscope worksheet. Again, if you have any questions on this worksheet, get a hold of me. So that way we can discuss it and get it figured out. That's what I'm here for. So, hey, we will talk to you guys later.